Hello everyone, so welcome back again. Here in the previous lecture, we have learned about minimum spanning tree and also Prim's algorithm about finding the minimum spanning tree. Today, what we are going to learn that is Krushkal's algorithm for finding the minimum spanning tree, right? So let me draw the tree and then one by one, step by step, I'll explain to you, right? So in a Prim's algorithm, what we do, just to recap, in a Prim's algorithm, we select the starting vertex and then we go for the adjacent vertices and we add the fringe to it, right? And after adding the fringe, what we do, we select an edge that is having the minimum weight, right? So here there is a difference, a small difference, that there we have that constraint that we need to go for an edge that is adjacent to the vertex that already we have added to minimum spanning tree. But here we don't have that constraint, right? So we just need to select an edge that have minimum weight, right? So that is the only constraint. Along with that, two things that we follow in Prim's algorithm as well, and even in the minimum spanning tree we follow that there should not be a cycle, so no cycle should be there, and all the vertices should be reachable, right? So these are the things that we need to keep in mind, otherwise we are ready to go. So this is my minimum, this is my graph, and for what I'm going to find the minimum spanning tree, right? So in this graph, if I go first, I'll draw the all the vertices first. Okay, so in the first step, I need to identify that which edge is having the lowest weight, right? So here, as you can see, that A, D, the edge A and D is having the minimum weight, that's a 1, right? So you just select this A and D with the weight 1, right? So previously you were having all the individual vertices, okay, and after selecting this, what you will have, this A and D are connected and rest are still single, so we can consider them as a forest, right? Okay, now after this, again we need to go for which one is the lowest. I'll do one thing, I'll just list all the edges with its weight, so it would be easy for you as well as me to identify. This AB is having 7, AC is having 6, AD is having 1, then BC is having 8, CD is having 5, CE is having 3, DE is having 4, DF is having 5, and EF is having 2. Yeah, so I hope all the edges are there. Yeah, so in a first step, what we did, we selected this A and D, right, with the lowest weight. So we selected this and made it in our minimum spanning tree. Now the second lowest, as you can see that here, E and F, right? So E and F are the second lowest, so we just select it and add it to my minimum spanning tree, right? So after that, what I'll get, that I have this AD as a tree, B is still single, C is still single, right? E and F are connected, right? Okay, now again we need to find the minimum. So you can say that here you can see that this CE is having 3, right? So we just select the CE, right? So if I select the CE with 3, right? So after that, what I am having, this A, D are connected, B is still single, C is connected to E, so this C, E and F, this will be a one tree, this is a single tree, and this is individual, right? Now we need to go for next edge that is having the minimum, right? Now here you can see that 4, this 4 is having minimum, but it is connecting D and E, right? So do we need to connect D and E? Because D is also in my minimum spanning tree. E is also available in my minimum spanning tree. So there's a question, you might get the question that do we need to select it or not? What to do? Now here, as you can see here, A and D are connected to each other, C, E and F are connected to each other, but still the both trees are distinct. They two are different to each other, they are not connected with each other, right? So, and after adding that edge, it will not generating any cycle, right? So if I add this edge D and E, so it will join, this two trees are disjoint till now, so it will join this two. So what will have this 4, right? So after that, this A, C, D, E, F, this all 5 vertices are connected to each other and only B is remaining, right? Now if we go with the next lowest weight, right? So you can say that this D and F, right? This D and F is having 5. But if I join this D and F, if I join this, then it will generate a cycle, right? And we don't require that because already the vertices are inside my minimum spanning tree, so I don't require it, right? So I'm just discarding this, right? Then the next lowest is C and D 5, right? Again the same thing, if I join this C and D, right, then what will happen? Again it will generate a cycle, and that I'm not requiring, right? So I'll simply discard it, right? Now the next lowest is A and C 6, right? um So if I join this A and C, again the same issue, it will generate a cycle, right? So I don't require it, row, I'm deleting it. So I'm just discarding this. The next lowest is a 7, A and B. And here as you can see that B is still alone. So by adding this age, I'll join this B with the existing tree. So after this, I'm having this A, B, C, D, E, F. As you can see here, all the vertices are available and all are connected to each other, making a one tree, right? So this is my minimum spanning tree. So no need to go further, right? This B and C, this is just an extra that we need to discard it, right? So after this is your final minimum spanning tree, right? And if you want to find the cost, so cost of it, that is 7 plus 3, 10, 10 plus 4, 14, 15, 17. So cost of this is 70, right? So I hope you understood it. This is Krushkal's algorithm. It is more easier than Prim's algorithm. Actually both are easy. The only thing is in Prim's algorithm you need to go via the adjacent node only, right? Here there is no constraint such, so you can go directly as well, right? So yeah, that's it about Krushkal's algorithm. You have learned Prim's and Krushkal's algorithm. So I hope you understood it. Thank you for watching this video.